Well, like you say, I've been in this community for a while, so I think this, I started going to ISITs in Les Arcs in 1982, so it's a long time. I think that the attitude of this community to Shannon is a little bit unusual. I mean, in the sense that mathematicians don't venerate great mathematicians like Gauss or Fourier in quite the same way. And I'm not sure that it's completely healthy, in the sense that I think that one of the great things about Shannon... Yeah, it's probably a good idea. That's it.
Can you get the mics up?
So hand up mic or?
That's it.
Mikey gets that.
Yeah. So, and I think that it's a little bit unusual the way that this community venerates Shannon. And I said, well, mathematicians, I mean, great as Gauss, Hilbert were, they're not venerated in quite the same way. And I'm not sure that the veneration is completely healthy. And I think that one of the great things about Shannon was that I think that one of the great things about Shannon was that he looked out at the world the way it was, and that he made models that captured the world. So for Shannon, the Gaussian model of point-to-point communication in the presence of noise, that was a crystallization of engineering practice. It also happens to be a very challenging mathematical problem. And I think that if Shannon were alive today and in this prime, he would be looking out at the world of communication as it is today, and he would be making new models. And I think that sometimes we lose a little bit sight of that.
Are we okay? Yes.
I hope so.
I also, perhaps this is one of these occasions where one person could speak at a time. I don't know.
I think it's the other microphones first. There are this feedback. There's two microphones.
I switched the others off.
This one is switched off.
That is off.
So
The other one, the stand
The
up, the
stand
one stand
one,
on the
okay,
seat.
that's not
I've muted that as well.
So it's great, but it's not. Doesn't seem to be. No, it's working. All right, good. And what made me think of this was, I mean, point-to-point communication was a challenging adversary. We worked on it for a long time, and we finally more or less beat it. Today, what's important is communication in networks. What's important is interference. And one of the recent things that I remember is when David Say and Salman Avestamar and Suraj Tagavi came up with a deterministic model for wireless communication and an abstraction of interference. The community did not wholeheartedly say, ooh, a new model, let's work on that. They had a little bit, the attitude was of, so what's wrong with Gaussian noise? And I think that we could spend a little bit more time making new models and analyzing them, and in a sense being true to the spirit of Shannon, rather than working, rather than this priesthood thing. All right, fine. I think that you're the second most senior reverend. I think you're right.
I have to follow this script order. Alright, actually before I follow up with what Rob said, I would like to share with you something very interesting that I know of. Actually, I recall this interesting story because I just saw this video that was it in Israel, the ITW in Israel. Okay. So in the video, Sergio said that in his resignation letter, Shannon said that he was very keen on teaching. But what I knew was that he spent very little time in the office at MIT. How did I know that? Because Vincent Chen, a very good friend of mine, who's now a professor at MIT, keeps bragging that he was an office mate of Shannon. So what happened was that when Shannon was hired by MIT, he rarely went to his office, to the extent that after a long while they decided to give the office to the graduate students. So Vincent Chen was one of the graduate students being put in that office, and that's why he claims that he's an office mate of Claude Shannon. So I was very surprised that they, in the resignation letter, Shannon said that he was very keen on teaching. I don't know exactly why that was the case. Anyway, coming back to Rob's comment on the attitude of this community towards Shannon, I would like to mention just one thing that I believe is the case personally. Okay. I think for people like us who study Shannon theory, I think the most important thing, well, it is important for us to know what the results of Shannon's are, but perhaps more importantly, we should pay more attention to how Shannon was able to come up with a theory from scratch. Okay, and I think that's the most important thing. Right? I think that to me, this is the most essential spirit of Shannon theory. Okay? If we can know this secret of how one can come up with a theory from scratch, then perhaps we can build some other theories based on the same spirit. Okay. Who else?
So if anyone has anything to share, please feel free. We can also open it up to the audience for questions. I promise. So I've tried to take your words to heart and give you chances to interact. This I promise. I realize that there's also perhaps such a thing as too much interaction, right? So let's say that this is the last opportunity that you'll have to bother people here. But if there are any questions that people have in the audience for the speakers, or if the speakers would like to share any last words of wisdom with the audience, this may be something that an opportunity to do that. Anything that anyone would like to say?
Well, yeah. So I'm pretty much, I can say I'm perhaps an interested outsider of the information theory community. I publish paper on CSCIT and IT transaction, but most problems I'm working on are not traditional IT problems. So I just want to echo to Raymond's opinion just now. If you learn the way how people create good things, then you can apply similar spirits and methods to do something also very nice in other domain. Personally, I think this is what I benefit from by interacting with colleagues here at CHK, those IT information theorists. One thing I learned from them usually is that they try to, there's two weapons I learned. First is you always focus on the common case. To me, the probability and stochastic, this way of thinking, and typical sequence, typical set, all these ideas, typical events, allow you to focus on the common case, the majority of case, and leave the common case out of the picture. And this allowed you to being focus on the most important part of the problem, and leave out all the trivial details or not important details. I think this spirit has been very helpful when we try to tackle problems from in smart power grids to data center energy saving. And the second thing I learned is that from information theorists is that whenever they encounter a problem, instead of directly try to come up with a solution, they ask the first problem is that what is the performance limit? Okay. I think Peidar, one is one of the undergrads here, he has been working with me for 1 year. We're working on a problem where the problem is about if you have a time reversible Markov chain, and you're happy with is a steady state distribution, but you're not so happy about how fast it converge. Right? We call this mixing time. So the question is how can we make it mix fast? Then there is an approach proposed by Steve Boyd in Stanford. What they call the faster mixing Markov chain is by adjusting the transition rate across different states, and then you try to optimize the second largest eigenvalue of the transition matrix. So this way you get the fastest mixing Markov chain. Okay, and of course you can do bunch of other things. But then the question we try to answer is that suppose we allow you to touch the transition rate as in any way that you want. Can you change a slow mixing Markov chain to a fast mixing Markov chain? Okay, essentially a performance limit question. And I think we try to ask this question mainly because the influence from I got across many years from information theorists. And at the end, Peter has done very nice. He has obtained very strong negative results, saying the answer is no. So if you want to make the Markov chain fast mixing, you cannot just work on its transition rate. So yes, that's my personal experience with on how why learning information theory or interact with great people in the community can actually benefit you, even if you're not working on this area.
Well, in information theory, we don't call it a negative result.
Okay.
We call it a Thomas Coding theory.
Everything is a result. Yeah. Everything is
I share some of, I do share Rob's views, I guess, on what I like to call the cult of Shannon within the community. There is indeed kind of a veneration that one sees of Shannon within the information theory. Let's call it the in crowd, which to a mathematician or someone who is not so much of so much within that in crowd. Seems a little strange, I have to admit. I guess one reason for this is that information theorists at least oftentimes say that it is a theory whose origins can be pinpointed to this sort of 1948 landmark paper by a single author, Shannon. Fair enough. Raymond called it sort of designing a theory from scratch, or which I take issue with. Nothing comes from scratch. You always work off the work of others. In this case, without say Wiener or Nyquist, Shannon's theories probably would not have existed. So yeah, I think it's flights of fancy. It's the imagination that probably sets Shannon apart from sort of his contemporaries of that time. Yes, so these are just some random thoughts, but I agree with the fact that it's like, sort of venerating, pinpointing just one person. Okay, he may be the founding father of a field, but sort of putting him on a pedestal and like sort of venerating him seemed a little excessive. And I'm not sure how much of that sort of will continue to remain as sort of we have as the torch passes down to people who were perhaps a little further removed from Shannon and his days, like sort of people who were not particularly associated with Bell Labs or I mean, there's like a younger generation of information theorists as that sort of which is going to who are going to take up the mantle, so to speak. So I'm not quite sure whether that level of veneration will continue to remain. But yes, but it will be interesting to see how this pans out, I suppose.
Yeah, just wanted to say something, kind of an observation. In physics, there is kind of Einstein. At least in the pop culture, he's like the physicist. So I don't know actually in the physics community what they think of Einstein, but at least in the pop culture, he's Einstein, and then nothing comes after Einstein. And it seems like he did everything out of the blue. But yeah, I mean, there were obviously Minkowski and many other people with important work. I mean, obviously Einstein did important things, but he didn't do out of the blue. I mean, and the same thing with Shannon. Obviously, people did interesting stuff before, but yeah, Shannon did very important stuff, but he's not the only one. So if you really put emphasis on people, then there is certainly more than just Shannon. Shannon was a very important person, but many different people have contributed in their ways to information. One more thing I also wanted to say with respect to models. I think that's kind of the important thing. I mean, once you have the model, so to speak, the mathematics comes out of it. So the important thing is really models. So I encourage you to